Good evening, everyone. This is the flipped lesson for slope of lines. If you've not taken the pre-video survey that's listed in Schoology along with this video, you need to stop and take it now. And if you have taken that survey, then just have your notes out and be ready to review slope of lines and see how it applies to some of the concepts that we've been working on in geometry class. One of the other things I want to challenge you to do is that if you do have questions as the video progresses, go ahead and post a comment underneath the video and see if somebody replies to you later. You might get the answer before you come to school tomorrow. So the definition of the slope of a line is the ratio of the rise to the run. So we're talking about the rise vertically and the run horizontally. So if x1 and y1 and x2 and y2 are any 2 points on a line, then the slope of the line is going to be the slope formula, which is y2 minus y1, the difference in the y's, so that would be the rise, and then over x2 minus x1, which is the difference in the x's, or the run. One of the symbols that you see sometimes along with slope is it looks like a little triangle. It's actually called delta. Delta literally translates to change in. So if I talk about the change in y's or the change in x's, I would write a delta y and a delta x. So I have delta y over delta x means delta y over delta x, and it translates to the change in the y's over the change in the x's. So for example 1, I want to determine the slope of the line if A is a point at 8, -3, and B is a point at -4, -12. So I'm going to go ahead and sketch a graph so I can see kind of what my situation looks like. If point A is at 8, -3, then that means that I'm going to move roughly 8 spaces to the right from the origin and then down 3. So it's somewhere over here. That would be point A. And then point B would be at -4, -12, so that would be somewhere over here. And this would be my line AB that I'm trying to determine the slope of. So if I find the slope, I need to find the change in y's over the change in x's. So my change in y's would be y2 minus y1, and my change in x's would be x2 minus x1. So I'm going to label my points. Point A is going to be my first point, and point B is going to be my second point. 2. So I have -12 minus -3, and I have -4 minus 8. So -12 minus -3 is like -12 plus 3, and -4 minus 8 is -12. I simplify and I get 3/4. So here my slope is a rise of 3, a run of 4, which is reasonable because based on my picture, it looks like I'm rising a little bit less than I'm running, and I'm going in a positive direction. So we've talked about parallel lines a lot over the last few days, and we've talked about transversals. So if we have something like that on a graph, we need to discuss the slopes of parallel lines. And you'll recall from the last 2 years of algebra that in a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope but different y-intercepts. And it's important to talk about same slope and different y-intercepts because if they have the same slope and the same y-intercepts, they would be the same line. The other thing that we need to discuss is that in the parallel lines portion above, we talked about 2 non-vertical lines. However, any 2 vertical lines are always parallel to each other. For perpendicular lines in a coordinate plane, 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. Remember that product means multiply. So if I multiply the slopes together, I should get a product of -1. And another way that some people like to determine if the slopes make perpendicular lines is that they identify if the slopes are negative reciprocals of each other. So they need to be negative, so opposite signs, reciprocals. An example of that would be 1/2 and -2, because -2 can be written as -2/1. So they're opposite signs and the fractions are flipped. That's what it means to be a reciprocal. The other thing that we need to discuss is that horizontal and vertical lines are always perpendicular to each other. So in this example, we want to find the value of y that satisfies the given conditions. The line containing -4, 9 and 4, 3 is parallel to the line containing -8, 1 and 4, y. So y is the value that we need to find. And if these lines need to be parallel, that means that we need to have the same slope. So my goal is to figure out what the slope of the first line is and then make the second line have the same slope. So I'm going to use my slope formula for the first line. That would be y2 minus y1 over x2 minus x1. Remember, it's always good to start with the plan. So in my first line, I have 9 minus 3 over -4 minus 4. 9 minus 3 is 6. -4 minus 4 is -8, and that simplifies to 3 over 4. So here's my slope of the first line, and I need my second line to match that slope. So I'm going to do my slope formula again, but this time with these 2 points. So I have y minus 1 over 4 minus -8. Y minus 1 on top, 4 minus -8 would be 12, and I need that to equal -3/4. So in order for it to equal -3/4, I need my denominators to be the same, which means that I need them both to be 12. So in order to make this denominator 12, I'm going to multiply by 3. So I have -9/12. So here, I have y minus 1 over 12. And that should equal -9 over 12, which means I have an equation right here that I want to try to solve. So if y minus 1 equals -9, that means y has a value of -8. For the remaining 3 problems, I want you to go ahead and answer them, see if you can determine if they are parallel, perpendicular, or neither. We'll discuss them tomorrow, and don't forget to take your post-video survey. Have a great night.